All right, what is up? Welcome back. We're going to continue today talking about relationships between two variables, and we're going to still focus on linear relationships for right now. So far, we've talked about a measure correlation on basically how to show the strength of the relationship between two variables. We're going to kind of continue with that sort of theme today, but now we're going to make predictions. So we're going to use what's called the least squares regression line, and you have probably heard of that, but more as what's called the line of best fit. And this is just a fancier word for the line of best fit. And I'll just say it's the line that best fits data to show a linear relationship between the two variables. Now, the reason it's called the least squares regression line is because we want to have the line be as close to the squares of the data points as possible. And the reason we use the squares of the data points and not just the actual data points is because we want to get rid of negative values because when we square it, it just becomes a positive. So that's why we say the least squares regression line. And we'll get into a little bit what regression means later. But it's essentially saying we regress from the line as little as possible. Okay? So the way we're going to do this, and I'm not sure how to make this on here, but we're going to have our formula is just a regular line. And that's just your y equals mx plus b. Now, the y actually has a hat over it, which kind of looks like this. It's like your little exponent form. And what that means, and it's supposed to be on top, but I don't know how to make it on here. So y hat, we call it, is just our predicted value of y. All right, and we're going to show this on the calculator again, how to do that. And we're going to use the same data values we did in the last video. So you might still have some of that data in there. I'm going to go to, I don't know what that is. Back again are fast food sandwiches, the fat versus the calories. And we get this calculator up. So we're going to put this data in again. And basically, it's not going to be too much different than what we did last time. But we're just going to get different information out of it. And then our calories. All right, so again, if we want to look at a scatter plot, which we do, and I'm not sure if your calculator is on your desktop, reset the memory. So you may not have to go through this whole shabazz again, but we know how to set our window already pretty well. So I'm not going to go through it again. I'm using probably about the same stuff I did last time. And here's our scatter plot. Now, again, I don't know if your calculator resets the memory. So I'm just going to turn my diagnostics on again, just in case. And if you remember, you hit second and then that 0. And then we scroll down to diagnostics on. Just so that'll show us the correlation again, and hit enter. And now we're going to go stat. We're going to go over to calc and linear regression. And this is the same way we found the correlation last time. And you'll notice that not only does it give the correlation and the square of the correlation, we probably won't get into R squared, but it gives us A and B. And A and B is just the slope and the y-intercept of our line of best fit. So let's round to 2 decimal places, and we'll say that our slope is 11.73, and our y-intercept is 193.85. All right, so, and then we can just put this into our y equals and just show that right on our scatter plot. So our equation is 11.73x plus 193.85. And you'll see that we get a line of best fit here. And that's pretty awesome. All right. What we're going to use this line of best fit to do is to make predictions. So basically, what we can do is we can figure out for any amount of fat within a reasonable, we don't want to go too far away from the data we have. That's called extrapolation. But within a reasonable data range, and our data seems to go from 5 to 34. So anything in there or slightly outside it, we don't want to do like 100 grams of fat because that might not be accurate. It might, but who knows? But let's say we wanted to find the predict the total number of calories for a fast food sandwich that has, say, 10 grams of fat. Okay, well, all we do is we plug it into our formula. And remember, y hat is equal to, and we just put this in the calculator, but I'm going to write it again here. So I have it here. And I already forgot what I just said. We said, I think, 10 grams of fat. So let's say y hat is equal to 11.73 times 10 plus 193.85. And then we just calculate it. And we get that y hat equals 311.15 calories. So we can make a pretty good prediction based on if a fast food sandwich has 10 grams of fat, we can predict that it would also have 311.15 calories. And it's just a way for us to make predictions. Now, does that mean it's going to be exactly 311.15 calories? Probably not, but it's going to be pretty close. All right, most likely based on the data that we have. So that's what we would use. All right, so that's how we make predictions based on our least squares regression line. And this is really valuable for lots of different things you're doing. Let's say you own a business, you often will see the relationship between sales and profit. And you want to make predictions based on if I sell this much, all right, my profit's going to be this. And you use the least squares regression line. All right, there's millions of other things you can do with it as well. That's the first thing that's coming to my head. All right, let's try it again with our other values that we used before. And this was talking about a car. And remember, the more you drive that car, the less it's going to be worth. And that was pretty unsurprising. Got to clear that, and I just typed over it, which is kind of annoying. I'll clear it in column 2. Sorry, the input of my data takes a while. Hopefully you're following along with me. Hope everyone's having a wonderful day. Really happy with the feedback you guys gave me on your remote learning. I think for the most part, we're doing a great job, so I'm really proud of you. All right, so again, actually, let's look at the scatter plot first. Remember our miles driven, we went to, let's say 160. Let's go by tens, Ys. That. Here's our scatter plot. Don't want that anymore. Stat calc. 4 linear regression. All right. Remember our correlation was negative, and we can see that, right? It's a pretty strong negative correlation. We can tell that by looking at our graph. And we have a slope of our least squares regression line of negative 0.19. If you got something that wasn't negative, you would know there's a problem. And our y-intercept b is rounding to be about 39. So let's put this in here. So we have negative 0.19 x plus sorry, plus 39 graph, and now we have our least squares regression line. And again, we can use that to make predictions. So I can pick any miles driven within reason. So I could say, what if we have a car that we drove 100,000 miles? Okay, well, I would just plug 100,000 into this equation, 100 because we're in thousands of miles. And that would just be, and I'm not sure if you know how to do this on your calculator. You can use the table function and scroll, but that's kind of annoying. If you hit second window, this gives you your table setup. So you can decide where your table wants to start, and this is how much it's going up by. But even easier for a situation like this, if we go for independent to ask, what this is going to do is I can put in any value for x, and it's going to get me the value for y. So what this is saying is if I plug in 100 into x, meaning if we drive 100,000 miles, then our car price is going to be 20,000 bucks. All right, and I can put in any number here, and it's going to give me an output. It's a pretty neat function in your calculator. Let's say 200,000 miles. All right. So this is again kind of extrapolation, but might be true, right? If you put 200,000 miles on your car, it's going to be worth about $1,000. Probably not that much. So it may be accurate, but it's kind of far out of our domain of our normal data. But I think it actually might be pretty accurate. If I say we only have 2,000 miles on it, all right, then my car is going to be worth about $38,000. All right. So this is how we make predictions based on least squares regression lines. Good luck with the assignment. Again, I think we're doing a great job so far. Keep it up. If you have any questions, just ask. Peace out.